7.4 Similarity in right triangles. All right, example 1. When you draw an altitude to the hypotenuse of a right triangle, you create 3 right triangles. How are the right triangles related? Okay, so I'm going to create a right triangle. Okay, so I have a right triangle. Okay, so we've got a right triangle, and it's telling us that when we draw an altitude to the hypotenuse of the right triangle, then we create 3 triangles, 3 right triangles. Okay, so I need to draw an altitude from my right triangle. Try to get my ruler up onto my screen so I can get this a little straighter for myself. Okay, so let me drop my altitude down. Okay, so there's my altitude, and when I drop that down, it's creating 2 more right triangles. So in total, I have 3 right triangles. Okay, I'm going to go ahead and name my angles. And then my altitude would be D. Okay, so we know that angle ADC is congruent to angle ACB because they're both right angles, and that angle A is congruent to angle A. Right, because we know those, then we are able to say that triangle ACD is similar to triangle ABC by angle-angle similarity. Right, we're also able to say that angle CDB is congruent to angle ACB because those are both right angles, and we are able to say that angle B is congruent to angle B because they're both the same angle. Because we can say that those 2 angles are the same, then we are able to say that our other set of triangles are congruent. Okay, because we're able to prove that those 2 triangles are similar to each other, then we are able to say that triangle ACD and triangle CBD are both similar to triangle ABC. Okay, or try it. How is triangle ACD related to CBD? Okay, so we know that angle ADC is congruent to angle ACB because they're both right angles. And we know that angle A is congruent to angle A because they're both the same angle. So triangle ACD is similar to triangle ABC by angle-angle similarity. Okay, our next one, we can show that angle BDC is congruent to angle ACB, and that angle B is congruent to angle B because they're the same angle. So triangle CBD is similar to triangle ABC. Because we are able to prove both of those, we are able to prove that triangle ACD is similar to triangle CBD through the transitive property. Next we have our right triangle similarity theorem. The altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. Okay, so that's what we just showed with example 1. Example 2. Given that triangle PQR is similar to QSR, what is the measure of QS? So we're trying to find this measure. So we're going to set up our similarities. So QS is what we're looking for, and that would be similar to PQ. So QS is similar to PQ. And SR would be similar to QR. Right now I'll plug in the information that I have. So we're looking for QS. PQ is 20. SR is 9. QR is 15. We'll cross multiply. So QS will end up equaling 12. All right, A, write a proportion that you can use to solve for PS. So we're trying to find PS now. Okay, so then my similarity PS, so side PS would match up with QS. And then we would have PQ, which would match with QR. Okay, so A, we're only writing the proportion. We don't need to solve. B, we are actually solving it. So PS, QS, we're going to plug in 20. PQ, oh, hold on, not 20. QS we solved in example 2 was 12. PQ is 20. QR is 15. Cross multiply. So PS will end up equaling 16. All right, example 3. given triangle ACB, what is CD? So we're looking for CD. That is very large. Zoom in. Looking for CD. All right, so setting up our proportions, AD would match up with the CD that we're looking for. And the CD that we are looking for would match up with the BD. Okay, so for this one, they only gave us 2 measures. Go ahead and plug in the information I know. AD is 6.4. CD, we don't know. BD is 3.6. All right, we'll cross multiply. CD times CD, I get CD squared. 6.4 times 3.6, I get 23.4. To get rid of my square on my CD, I'm going to take the square root. So I'm left with CD equals 4.8. Right, A, or try it, or A, what is CD? So again, we're looking for CD. CD would match up with AD, and then BD would match up with the CD. We don't know what CD is. AD is 5. BD is 15. Cross multiply. To get rid of my square, I'll take the square root. So CD will end up equaling 8.6. Repeating. All right, B, describe how you can use the value we found for CD to find AC and BC. So we found CD to be 8.6. We could use that to find AC now and CB by using the Pythagorean theorem. Okay, so because we now know 2 of the side measures of a right triangle, we could plug those into the Pythagorean theorem to solve for the missing side, which would be the hypotenuse side. All right, right triangle altitude theorem. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay, so example 4. We have triangle RST, and we want to find what RT is. So we're looking for that measure. Okay, we can use our geometric mean to help us solve that. So we would have RS over RT, which is what we're looking for, would equal RT over RU. Okay, RS is my 2 segments added together, which I would get 15. So RS is 15, my geometric mean. RT is what we're looking for. RU is 9.6. Cross multiply. Take the square root. So RT will end up equaling 12. Right, try it. A, what is JL? So we're looking for JL. We're going to use our geometric mean. So JK over JL equals JL over JM. Okay, JK is both of my segments added together, so I'd get 24. So 24 over JL, which is what we're looking for. JM, the segment is 4. Cross multiply. Take the square root. So JL will end up equaling 4 square root 6 or 9.8. Okay, next we're looking for KL. Change my colors. So KL, we're looking for the other side. So MK over KL equals KL over JK. MK is 20. And 24 for JK. Cross multiply. Take the square root. So I get 4 square root 30 for the measure of KL. All right. Geometric mean theorem. The altitude to the hypotenuse of a right triangle divides the hypotenuse so that the length of a given leg is the geometric mean of the length of the hypotenuse, and the length of the segment of the hypotenuse is adjacent to the leg. Okay, so let's look at example 5. What is the value of x? Okay, so we have our segment here, x plus 5, and then our other segment, which is x. So we're going to set this up. X plus 5 over 6 equals 6 over x. Cross multiply. Distribute. I'm going to subtract my 36 over. All right, I need to factor. Okay, and when I factor, I use the magic X to help me factor. Okay, so I multiply A times C, so 1 times the negative 36, I get negative 36 on top. Okay, and then B will go in the middle on the bottom, so 5. So I'm looking for two numbers that will multiply to negative 36 but add to a positive 5. So I want to find all my factors of 36. So 1 times 36. 2 times 18. 3 and 12. 4 and 9. Okay, so 4 and 9, if I add those together, negative 4 and positive 9, that would give me 5. So I have negative 4 and positive 9. So my factors are going to end up being x minus 4 and x plus 9. Solve each of those individually. So x minus 4 equals 0, x plus 9 equals 0. So x equals 4. I cannot have a negative value for a side, so my x has to be the 4. So length always has to be positive. In our try it, we want to find the value for y. So 13 over y would equal y over 4. Cross multiply. Square root. So y will end up being 2 to the square root of 13. Now we want to find the value of x. So 13 over z equals, or we're looking for z, sorry, z over 9. Cross multiply. Square root. So z will end up equaling 3 square root 13. All right, example 4, we want to use the geometric mean to solve a problem. All right, so we're constructing a 4-foot high loading ramp. The length of the back of the base must be 12.8 feet. How long must the entire base be? So our length of the back must be 12.8. And we want to know how long the base has to be. Okay, so we're looking for our front measurement here. We're going to call that x. So x over 4 equals 4 over 12.8. Cross multiply. Divide by 12.8. So x will end up being 1.25, which is our front measurement. We want to find the total base, so we're going to add our back, which is 12.8, and our base, which is 1.25, together to get us 14.05, and this is feet. Okay. How long do we need to make the ramp? So now we are looking for this measurement. So we're going to set this up as x over the 14.05 equals the 12.8 over x. So we'll have x squared equals 179.84. Take the square root. So x equals 13.4.